Hi, I'm David Bone, and today I'm going to be talking about my report on modular thorium molten salt reactors. I see thorium nuclear reactors as a potential solution to the energy crisis that we currently face globally. Just here's a brief overview of my presentation. I'll be talking about my purpose and audience, which is actually something that I spent quite a bit of time wrestling with because I knew that I was interested in thorium, but I also didn't know my role in writing this report and to who I was going to write it to, but we'll talk about that in just a minute. We're going to go through the problem that we currently face on the global energy market and then really focus in on the research and the design of thorium reactors. So, the purpose of my report that I'm writing is to inspire young people who are going to be in the STEM fields or future policymakers and leaders, because I understand that I'm currently in school. I do not have a degree, and therefore I do not have the credibility that people older than me would. So what I want to do with this report is to try and engage my peers, my contemporaries, people who would be able to listen to me as somebody kind of on an equal playing field with. And so that is my audience, are my contemporaries, people that aren't the CEO of an energy corporation or aren't a policymaker, but will be in the future. That way I can really help to at least give them what I think is the potential value of thorium reactors on our national energy grid. So the problem that we are facing is our current energy production is not a sustainable way to produce energy. Currently, or as of 2013, which was the most recent data I could find from the EPA, was that 66% of the U.S. energy production came from coal and natural gas. Those two fossil fuel sources made up, the vast majority of our energy production. Obviously, these both use fuels that are being burnt. They are non-renewable, so we will run out eventually. Granted, there is debate on when we will, but the consensus is obvious. We are going to at some point. They also have negative impacts as far as carbon emissions go. Burning coal, and to a lesser extent natural gas, is bad for the environment. There's been a lot of talk in media and on the national policy level of curbing carbon emissions as really a detriment to our both human health, nature, global temperatures, and then maybe even increasing severe weather patterns. So there's been a lot of buzz about the problem with carbon emissions. Non-fossil fuels also have their own inherent problems. Conventional light water uranium reactors, which is what we currently have, all commercial nuclear reactors are light water uranium reactors, whether the U.S., Japan, France, it doesn't matter. And we will talk more about their design differences with thorium molten salt reactors here in just a minute, but they have inherent dangers, as we saw at Fukushima Daiichi, Chernobyl, and 3 Mile Island. The problem with wind and solar, which are a current green energy source, is that they are unreliable. They do not have the ability to produce a constant energy supply 24 hours a day. The wind blows harder and softer or not at all, and the sun doesn't shine at night. These are obvious things, but it means that solar and wind require energy storage. And the best way that we have to do that currently is battery technology. And batteries are very expensive and adds to the cost of wind and solar, which already have been a rather prohibitive factor. However, especially with solar, it has gotten better in recent years. But again, that's not counting in the costs of batteries. In order to store massive amounts of energy that can power the national grid when production is down. Another problem with these batteries is the environmental impacts, because one of the biggest advantages to wind and solar is that they are green energy sources. They are supposed to be good for the environment, but the lithium mines in South America that produce the lithium for the batteries have received a lot of really negative press about the damage they have done to the local environments there. Also, hydroelectric, I would actually say, is an excellent source of power. However, there just are not enough fast-moving rivers and streams in order to provide our current power demands. So We currently do utilize hydroelectric, and I think that we still will, and it's a good thing. It is just kind of at its limit already. So the research I've done focused on thorium reactors, specifically modular thorium molten salt reactors, and even more specifically than that, liquid fluoride thorium reactor. So basically, you see a diagram here that I got from SciShow, and it is a very simplified diagram of a thorium reactor, and we'll talk about some of the differences between that and a uranium reactor. Basically, these reactors use a molten salt as its cooling source to keep the reaction cool and under control. That is huge because these salts can be at a very high temperature in their liquid state, as opposed to water, which we all know boils at 212 degrees Fahrenheit or 100 degrees Celsius. In order to be able to use that normal water as coolant, it has to be under extremely high pressure. And if anything happens to the lines or to the coolant system, that water can vaporize, expand into steam, and it's already under pressure, so it can expand, and then once it hits the open air, expand into steam, and you get massive steam explosions like we saw at Chernobyl. That's an inherent risk with any light water reactor design, so that's one advantage to these thorium molten salt reactors. Another is that because the nuclear fuel, the thorium, is suspended in a liquid reaction, and thorium is fertile, which means it can support a nuclear reaction, but it will not sustain one on its own. So a catalyst of either uranium-233 or plutonium must be present to sustain a chain nuclear reaction. So the liquid thorium suspended in a fluoride solution can drain into an emergency dump tank like you see at the bottom left of this diagram. That means that in the event of a disaster, a salt plug is allowed to melt and the thorium drains away and the reaction ends. This is huge for safety and is one of the biggest advantages of thorium over current uranium plants. There are also advantages in thermal efficiencies, but we really don't have time to cover that. Most of the research I've done has come from government resources like the Department of Energy, the Environmental Protection Agency, or the Nuclear Regulatory Commission. I've also referenced some scientific journals, but for the most part, it's from government documents. The work I've done, I have stayed on task, or on track, I should say, and submitted the first draft and second drafts on time. I've completed an introduction and methods section. I also have my findings section complete. However, it's not revised. I have revisions to do. So the findings for this project are that thorium, I believe at least, has the ability to compete with our current energy grid of fossil fuels and what has been proposed as the future being renewables. And we'll kind of break that down. And you may think it's odd that I'm not going to be comparing them as directly in this to uranium. However, the reason for that is uranium has already lost out. There has not been a new uranium plant constructed since the mid-70s. There is one that is currently being, I should say, considered by the Georgia Energy Company, but again, we haven't had a new uranium plant come online for 40 years. So uranium, I believe, has already lost out. So I'm going to compare thorium reactors to what we currently are utilizing. So a modular design, I've said that word a few times, and basically what that means is the reactors will be built in a factory, all the components will, and then they'll just be assembled on site. That allows the reactors to use interchangeable parts and saves massively on labor and construction costs. Interchangeable parts, as you know, was one of the huge advantages to the Industrial Revolution, where we saw manufacturing explode. This allows the cost, which has normally been one of the biggest prohibiting factors of traditional nuclear plants, is their upfront cost of, multiple billions of dollars, to be brought down significantly to the realm where they can compete with fossil fuels like coal whenever you factor in the fact that the running costs of a nuclear plant are so much less because they aren't continuously burning fuel. They're utilizing a chain nuclear reaction. So the running costs for nuclear are much lower, even traditional uranium, which is less thermally efficient than thorium. Also, thorium plants do not produce carbon emissions, which is, again, like we said, been a major talking point in the media and in climate sciences. They do produce some high-level nuclear waste. However, they produce much, much less than uranium per the amount of energy they generate. And thorium waste is only harmful for a few hundred years as opposed to uranium's few thousand. So that's, their byproducts are kind of in a different category. When talking about renewables, thorium plants offer reliability. They run constant voltage or power output 24/7. It does not matter. Where the renewables of wind and solar cannot match that. It's so thorium does not depend on batteries, and they are just shown outclassed really in reliability. Thorium's as good as coal or natural gas as far as reliability, or old style nuclear. That's always been just a solid section for nuclear. Also, wind and solar need energy storage to be viable, like we've talked about. That adds a lot of cost, because we were talking about it on environmental impact, but as far as the costs go, the batteries are oftentimes as expensive, at least if not more, than the solar panels or wind turbine farms to produce the energy. So that, combined with thorium's modular aspect, if you build the reactors in a modular fashion, can bring their costs into a level playing field. And then the longevity, thorium plant will last longer than a solar farm or solar panels. And hydroelectric, as we've already talked about, is simply not plentiful enough currently. And there are negative impacts of dams on ecosystems. For example, I believe there's been some debates about this globally, but not as much in the U.S., that building dams over rivers and streams isn't allowing certain fish like salmon to return to their spawning locations, having a really negative impact on local ecosystems and wildlife populations. So that's just another thing to consider talking about these green energy sources. Oftentimes there's kind of a hidden dark element to them. Finally, the work I have remaining. I need to add citations into my paper, and I need to do an executive summary, conclusion, and my final edit. I'm not as far ahead as I would have liked to have been at this point, but I have also not gotten behind in terms of the assignments that have been due. So I'm satisfied, but I would like to have been further ahead. Now, I guess if you have any feedback, questions, comments, concerns, we'll have the discussion board coming up soon, so just put it there. And I'm actually excited to hear what you all have to say, because this is something that I'm interested in. I'd like to know if anyone else is. So, good night.